So in this video we're going to make a Laurent series of 6i over iz plus 3, where z is a complex number, so this is complex analysis, where z has got a real and an imaginary part, a and bi. A and b are real numbers and I is an imaginary constant, square root of -1. So when we're trying to make a Laurent series for something of this kind of format, it's a good idea to take something from real analysis. Now it's of the format a little bit similar to that, which is a real famous alternating series in real analysis, which is 1 minus z plus z squared and so on. And that is valid for absolute value of z is less than 1. That way that will converge to a value. If it's 1 or greater, this will diverge or alternate to a value off forever. So what we want to do now is try and get this looking something like this. So let's do that. So I've got 6i over iz plus 3. So let's take the 6i out. I'll have a 1 on the top. So that's pretty easy enough to deal with straight away. 1 over iz plus 3. And then I want to get this 1 here. So why don't I take out a 1 over iz as well? So then I've got 6i, let's keep that out, and then a 1 over iz, that's out. And then let's finish off what I need if I factor this out. So I'll have a 1 over something. Well, as it's iz, and this is iz, I've got a 1. I'll keep my plus sign. Now I'm going to need the 3, so I'll keep that. And then if I divide it by iz, 3 over iz times iz just gives me 3. So I'm back to where I was, and that's that thing set up ready for me to turn into a power series. So now if we use this as our building blocks, our input is going to be this bit here. And in this case, it's going to be this bit here. So now what we've got, we can use it valid with that as our input. So this would be valid for 3 over iz, or absolute value is less than 1. Now if we just simplify that off, absolute value of I is just 1. So then that gives us 3 over z is less than 1. That's a z, not a 2. And absolute value of z will then be greater than 3. So that's what makes that valid for this series here. So now my input here, I'm going to put into this series here. So I'm going to come to that at the end. I'm just going to deal with this bit for now. So 1 over 1 plus 3 over iz. So this is the biggest step first. Let's take care of that. So then that, using this, will be, actually this goes on forever. Let's keep the dots on there so we know we don't stop at 5. It goes on forever, but that just covers up our notation. So 3 over iz. So I've got 1 minus 3 over iz. Then it's squared. So it's plus 3 over iz squared. And then minus 3 over iz cubed. And then plus 3 over iz to the 4. And minus 3 over iz to the 5. And so on. Right, so let's just deal with this. So I've got 1, keep that, minus 3 over iz, that's fine. I'll deal with this I, the denominator, at the end. Then here I've got, here I've got 3 squared, which is 9. Then I will have iz squared, so I squared, which is minus 1, in which case I'm going to have to alternate this sign to a minus sign. And then I'll have z squared in my denominator. So that takes care of that one. This one, 3 cubed, so 3 cubed is 27. I'm definitely going to have a z cubed. And then an I cubed is just minus I. So if that's a minus I, I'm going to have to alternate that sign again to a plus. I'll have iz cubed. And then I've got 3 to the 4, so that's 81. I to the power of 4 is back to 1, so now I've just got z to the 4 for this one. And then finally this one, 3 to the power of 5. 3 to the power of 5 is 243. I'll have z to the 5. Then I to the power of 5 is the same as I to the 1, so that's just going to leave me with an I. So I've got an IZ to the 5, and again that goes on. Okay, now to bring us back into what we did here, I've got this 6I, so I've got 6I over IZ. Now I need to multiply my series here by this. Well, I can see here clearly the i's will cancel out, and that is just left with 6 over z. So now I need to do 6 over z into all of this. So now what I've got, just noting this bit here, multiplied it all, I've got 1 times 6 over z, which is 6 over z. Times this by 6 over z, I'll have minus 18 over IZ squared. And keep going through all the series. So then I've got minus 54 over z to the 3 plus 27 times 6 is 162, IZ to the 4, times that by 6, 486 over z to the 5, and minus, times that by 6, 729 times 2, 1458. IZ to the 6, and it goes on and on. Now what I'm going to do now here, I'm going to put in my big O notation, so I'm going to just add on OZ to the minus 7, because I know that's going to be the next term possible. So now let's just work on this and just simplify it. So now I've got 6 over z. Let's try and get the i's out of the denominator in, or these every other term here. So if I multiply this by I over I, so I times that by I and times that by I, and do the same on this one and on that one, what will happen is I'll end up with 18i in the numerator, and then I'll have z squared times I squared. Well, z squared times I squared is minus z squared, so this side is now going to change. So plus 18 over z squared, and that's an I. Keep this one. And now, as before, it means now that this sign will alternate, and I'll end up with an I in my numerator. So I've got minus 162i over z to the 4 plus 486 z to the 5, and now I've got another plus sign, 1458 z to the 6, and my O notation, z to the minus 7. And that would be my Laurent series for 6i over IZ plus 3. Okay.